Bipin Pradeep is co-founder of Gaia Smart Cities. He's going to be talking about for the next 20 minutes on the second use case. Please welcome Bipin. Can I have Bipin's presentation, please? Yeah, click it.
Thank you. Thank you, Gaurav.
Yep.
Namaste. Good afternoon. I have 20 minutes. I'm going to go straight to the point. But before me, Danilo and Prasad give an excellent, give you all a whole lot about tech. So I'm not going to talk about tech at all. This is going to be my agenda. We're going to slightly talk about what we at Gaia do. Danilo has already spoken about a bunch of things that we did together, so it'll be even shorter. I'm going to talk about what we offer, solution as a service, and then how we're trying to do scale. You'll understand that as you see my presentation, and I talk about why we need to achieve scale. And then finally, something about how we overcome some of these challenges, which I call disorder. So in a really one slide, in a quick gist, this is what we do. As of today, we monitor over 86% of India's cheese. And I say effectiveness because it's not about quality, it's also about managing the whole cost-benefit analysis. We monitor and make sure about 71% of India's butter is good for consumption, its whole effectiveness. And we also do almost 40% of India's airports, managing passenger efficiencies. And that number says 10% of India's railways, but it's actually more. We monitor about 1,500 trains as of today. In the gist, this is what we do. We monitor campuses, warehouses, railways, metro stations, airports, hospitals, food and retail, city public, and railway coaches. So while there's a whole lot of tech, which the others have given you, what I'm trying to do is just try to run a business, and struggling at that actually. So this is what we do. We give real-time visibility to the operations. We provide action engines. We optimize experiences and operations. We make whatever was previously digitally opaque, we make them extremely visible. And finally, we do a lot of governance monitoring. This is the span that this is the spectrum of operations, our spectrum of operations. This is how we impact your lives, the customers that we do. In numbers, that was percentage what you saw earlier. I think we touch at least 7 million users every day. So far, we have gathered 70 million unique user data points, users as in you and I. We have got over 150 million sensor data points. We monitor over 90 million square feet of built area. That means spaces like this. And we started off with cities. So we monitor over 450 million square feet of city areas. So that's the numbers that, that we do. And the reason I'm telling you all this is because of how we manage this. So in the gist, this is all that we do. We look at a site, airports, planes, trains, it can be anything. We gather data from that, say it's insight, and then we predict, which is what we call foresight, and we either improve processes or do workflow automation. That's it, that's what we do. It's a whole lot of IoT, but as you must have seen, I haven't spoken about IoT at all. We just do foresight, process improvement, and workflow automation. This is a business we're trying to run. These are the different form factors of the devices. Danilo's not here. Oh, there he is. He'll be happy to see that what we do with ST and a bunch of others cover these different form factors, right from a unit that gets sensor data to what you must have seen in airports. That also has sensors, by the way, to what you must have seen in Swachh Bharat. We do this for about 128 cities. We monitor their Swachh Sarvekshan, as they say, and different other form factors. This small piece is what does all of that. It has Wi-Fi, it has BLE, it has 2G, 4G, it has a facility for having multiple sensor interfaces over I2C, ADC, USART, GPIOs, I2C, different manners in which you can connect sensors. This is what it is. And it has over, allow me to brag, over 12 or 13 different ST components. So this is the piece. There are others too that how we connect sensors. You can connect over 20 different sensors. And I'm telling you this only because you will see how we connect sensors and what data we get out of that. This is it. This is what we connect different sensors through. It's as small as this. And I'll probably show you something even smaller a little later. Those are the interfaces. So what I've connected there and what you see is something that probes in vesicoolers. We monitor the temperature in vesicoolers, or maybe even for Amul in the chillers. Sensor data can come through Bluetooth. So you can have several of these units sitting around, as small as that, and the data comes through BLE or BLE mesh back into this unit that you see. So this is all live, as you must have understood by now. And what we do with all of this, and as I said, we just do two things: process improvement, workflow automation. If at all I talk about workflow automation and process improvement, the first example I can give you is an industry here in Bengaluru. We monitor the number of presses the machine makes. So the customers are not interested in the number of presses. The customer is interested in knowing how productive that machine has been. So you count the number of presses, it has been 80% productive through the day or 90% productive through the day. And as you can imagine, you can draw analytics, and then we find out that the machine is most productive on Fridays and Saturdays, not Mondays. It's the least productive on Mondays. So, customers aren't interested in how we do it. He just wants to know how productive his machine has been. We do this for Amul, where we monitor the Amul warehouses, where we monitor temperature, number of times the doors we open and closed. We ensure quality. It's ultimately about ensuring quality. We do this for toilets, really. You don't have to see whether the toilet is clean by somebody pressing. You can put a sulfur sensor in the, as a BLE or an ammonia sensor, and the odor that it generates will tell you whether the toilet is clean or not. And lastly, we do this for BSES Rajdhani in Delhi, where we monitor the power for high-value customers. And what we're trying to do is ensure efficiency. Multiple use cases using the same set, and it's not about IoT, it's about workflow automation, about process improvement. What we do over foresight, you can predict by gathering some of this data, you're able to easily predict over a period of time. Moving quickly, what I want to talk about is this. It is about how we manage these number of devices, how we manage these number of data points, because as you know, the minute something increases, the second law of thermodynamics kicks in. What is the second law of thermodynamics? It's a disorder. Somebody wants, I'm sure you're all science folks. Anybody want to tell me what the second law of thermodynamics says? It says the entropy of an isolated system never decreases, never. It may remain constant, but that constancy remains only if the processes are reversible. And as we know, no process is reversible. It also says that every system spontaneously evolves towards entropy or thermodynamic equilibrium, and that is the state of maximum entropy. Whatever we do, that's what you realize. We encounter disorder. It is what you call unfailingly there. How we manage disorder is sorry, before that, there are some relationships that I've managed to gather over a period of time, and that is, SaaS's solution as a service. If you're trying to do IoT solution as a service, it always increases, or rather it's directly proportional to the number of devices that you have. The more number of devices, your entropy is you're hitting entropy faster. The entropy of an IoT system always increases with a number of locations. I think we do over 200 odd locations, cities in India. It's a pain to manage them. It's a challenge to manage them, but we do. And of course, I thought of one way in which you could decrease entropy, and that is if you have good security and control features. I think a number of, there was a panel discussion on security earlier, and we have seen if you have good security and control features, it does decrease entropy. But of course, there is a thought experiment which Maxwell himself proposed. It says, how do you violate entropy? It's a thought experiment, of course. Well, as much as I said, everything is marching towards disorder, there is a thought experiment that he designed that says you may violate entropy. And his thought experiment is very simple. There is a demon there sitting across two chambers. It's a thermodynamic thing. So as the hot particles move, the hot particles are faster, obviously. So he'll open the door, the demon will open the door, and the hot particles go to the other side. So eventually you'll have two chambers with one with hot and one with cold. But remember, this is just a thought experiment. Practically, it has been proven, or so far it has not been proven otherwise. You cannot violate entropy. So how do we violate entropy or try to violate entropy in all these installations that we have? An IoT perspective. So we have two parts. One is what we try to do to escape entropy on the device side. And we say FOTA, COTA, you know what that is, firmware over the air upgrade, configuration over the air. And the other is applied information theory. And the last is what you saw, device versatility. I'll talk a little bit about that. There are other things too. How we manage operations. We have a fabulous operations team. We use extremely good middleware and a good platform, thanks to Azure. I hope the Microsoft folks hear me talking about that. And then, of course, there is the supply chain that we do to make sure, right from the devices, sourcing of devices, to making sure devices reach, all of that is done extremely well. To talk about FOTA, you know what FOTA is, but we have a multiple hierarchy. As you saw, I have devices that talk over BLE as well. And you need to manage the FOTA or the firmware on the BLE device as well as on the gateway or this. So how we manage that is actually taken us over 1.5 years to perfect, to manage FOTA on a device. I see my time going, so I'm going slightly faster. So we try to reduce entropy by building this, by actually having built this extremely good FOTA capabilities over the last 1+ odd years. We're more or less perfected. Just think about it. I mean, if I have to even upgrade something here in Bengaluru in Dodbalapur, the cost of service will wipe out my profit for the entire year. It doesn't work. I have to do things remotely. So yes, I try to reduce entropy by increasing remote management capabilities. COTA, configuration over the air. There's so many things that we can configure. Your connection details, your server details. You may need to change servers. You may need to change server hosting providers. You may need to change Azure properties. Your intervals of data sending. How is it that maybe you don't need all the time? Your Wi-Fi details, sometimes devices are connected over Wi-Fi. That has Wi-Fi too. In airports, Wi-Fi changes all the time. And imagine if somebody had to go to an airport. I mean, forget about going to the airport. The process to get into one and try to change it is complicated. Indicator notification details, you want alerts, you want notifications. How is that you want to change? We allow you to do that. And the FOTA details itself may come from a different server. So yes, so how we configure and then how we control. You need to control the device, your activation, deactivation. So several things that are involved with control and configuration are also done to reduce entropy. You all heard about information theory, Claude Shannon's information theory, but that plays an important role in how we use it. Prasad spoke about intelligence at the edge, but I mean, simple intelligence to apply, it's all that we learn from information theory, which says that the most unexpected events have maximum information. I think you all should be easily familiar with that. If something doesn't occur, I mean, everyday events don't really give you that kind of information. It's something that doesn't, an anomaly is what is important. So the value of information is inversely proportional to the probability of occurrence. That's something that information theory has taught us too. So if it doesn't occur that often, don't send it back. Why are you sending humongous amount of data back to the cloud? Process it at the edge, process it at where you are, and then take a decision and then move forward. And then, of course, information that you send over multiple pieces can probably be condensed into one. Yeah, so the total information of two or more independent or many is just a sum of individual information. So figure out what is the right data that you need to send. Instead of clogging the network, clogging your servers, figure it out. Figure out what is. That's what we have figured out. So we've increased the edge intelligence to make value of all of this and then send data. So yes, we have applied information theory hugely. Device versatility, you saw this. We have humongous number of communication interfaces. We have a humongous number of interfaces too, through which you can connect different sensors. But this increases, how all you can reuse the device, where all you can reuse the device, and therefore everything else. When you have something uniform, everything else becomes lesser to manage. And of course, again, like I said, I hope the Azure folks are listening. We use Azure as a middleware and platform. We use a lot of the virtual machine scale sets. Pretty much handed over a lot of things to the middleware so that the intelligence that we do at the edge can pretty much be what we manage. But of course, we have applied it in a way that is useful, in a way that is meaningful, and something that helps us scale across geographies. If I have to deploy something in Spain, I take the sovereign data space and deploy it easily, deploy it quick, without having GDPR issues, etc., facing there locally. And that is something that I must attribute to what has happened in the cloud space, even though we are on the edge. This is my last slide, and I say, even though I've spoken all about entropy and all the negative things, I say entropy is extremely essential. We can't do things without entropy. At the background, if you all can see it, it's a famous painting by Escher. Escher's a Dutch mathematical painter. See, it's a very interesting painting. As you see from the ground, it's land that morphs into birds. And if you look from the left to right, you'll see white birds and black birds, actually blue, but this is major that. You can never see the white birds and the black birds at the same time. It's almost impossible. And that's pretty much one of the things that I want to tell you. You cannot do multiple things in a way without focusing on one. Focus on one, try to get it right, and that is when you will try to reduce, that is when you will decrease entropy. So yes, the only way you can manage entropy with devices, processes, your middleware, your platform, your supply chain, your operations, all of that is only if you focus, only if you evolve in a steady, deterministic manner. You have to evolve. You have to evolve. There's no shortcut. That's something that I've learned. And the thing that we have learned out of entropy is that either you optimize your existing business, existing processes, existing devices, all of that, your middleware, your supply, you learn to optimize it, or you destroy it. You destroy it and you build it. You build anew. And that's what we've been trying to do. Thank you.
Thanks, Bipin. I would request Ravi Gururaj to please come to the podium and hand over the memento. Give Bipin a big hand. It's been great. They made my job easier. I don't need to police. Thank you.